Hi everyone, here we go on problem example 2b for our section 9.4 notes. The directions above read draw and classify the polygon with the given vertices, and then find the perimeter and area of the polygon. First thing you're going to want to make sure that you do is get that plotted correctly with labels, so -3, 4, 2, 6, 2, 1, and -3, -1. Okay. I'm going to go ahead and carefully connect those coordinates. Okay. Now remember, we're supposed to classify the shape. Right out of the gates, I'm not entirely sure. I see that I have a couple vertical lines. These ones are not horizontal, so that means they do not make 90. So square and rectangle are out of the conversation. So it could potentially be a rhombus or perhaps a parallelogram. So since I'm not sure yet, I'm going to actually hold off on classifying it. The strategy that you're going to want to do on this question, though, just like we did on example A, is let's kind of enclose this to create kind of an outside rectangle for us. That's going to allow us to kind of use some other strategies in terms of finding lengths and therefore naming that shape. Okay, I think a good strategy would be let's find the length of all of those sides. For HL, the beauty of this one is that I can simply count since it's vertical. So it has a length of 1, 2, 3, 4, 5, as well as JK, 1, 2, 3, 4, 5. Again, since those were just vertical, we could simply count. Now the other ones, though, are a little bit trickier. They're slanted, and therefore we're going to have to do a little bit of additional work. I think it would be helpful, once you get a value, you should absolutely write that into the picture. And then when it comes to the two kind of right triangles that we've created on the outsides, let's get some measurements of those lengths. This is a 2 by 5, 2 by 5. And same thing with the one down below. This one is a 2 by 5. What that's going to allow us to do is use the Pythagorean theorem to find the length of sides HJ and LK. For HJ, this length would be our hypotenuse, so I'm going to go ahead and set it up with 2 squared plus 5 squared equals the unknown side squared, which is once again our hypotenuse. So this comes out to 4 plus 25 equals x squared. I'm going to reverse my order here and put x squared equals 29. I'm going to square root both sides. And I believe that 29 is going to be a prime number for us, so we're actually left with x equal to the square root of 29. Now, if you want to be clever and efficient, you'll notice that this one down below also has lengths of 2 and 5, which means that this third side is going to be exactly the same that we just calculated, root 29. We would simply be repeating the same work. So that means that LK is also root 29, as evidenced by the work that we just saw. With that new information, I'm going to go ahead and put it back into the picture, root 29 and root 29. Now I notice that the square root of 29 is some number that's bigger than 5 and less than 6. So since these two sides are not the same as HL and JK, that means that rhombus is out, and therefore it has to be a parallelogram. So now that we've classified it, the last two things that we're supposed to get are both the perimeter and area. Perimeter is always nice and easy. That's simply the addition of all 4 of the outside pieces. So in this case, we already have those written down and organized real nicely. So it's going to be 5 plus root 29 plus 5 plus root 29. You'll notice that 5 and 5 can go together nicely. So that's going to be 10 plus, keep in mind this is 1 root 29 and this is a second root 29. So that means that you have 2 root 29s. It's not the prettiest of answers, but that technically would be our finished answer for perimeter. And now for area. This is a parallelogram, and we know that the formula for that is area equals base times height. The base for this parallelogram is going to be 5. I know it's standing up and down, but you could always rotate your paper. And the height, keep in mind, is going to be the one, it's the length from base to base. So my height I'm going to draw in orange. And what's nice about this is forming 90 degrees with our base, and it's just a horizontal line that I can just flat out count. 1, 2, 3, 4, 5. So we have a base of 5 and a height of 5. So the area would simply be 5 times 5, which comes out nice and clean to 25 units squared.